In the previous video, we were looking at minimizing all our situations. We had a situation where we wanted to minimize the total time taken for the 4 buses to come to go to pick up each sports team. And here we looked at minimizing the total work or the total cost of the quote. And here we wanted to minimize the total distance each car had to travel. Now you can use Hungarian algorithm to maximize instead. Now in this case, the table below shows the most number of items an operator can make at each machine. Assign each machine to maximize the number of items made. A capitalist dream, we want to make as many things as possible. So when we are asked to maximize, and this will always be mentioned in the question, either minimize or maximize, when we're asked to maximize, there's one step that we need to take before we move on to the Hungarian algorithm. So here's our maximizing process. It says, assigning tasks to people such that the overall cost is as large as possible, we need to do these things. First, subtract every entry in the cost matrix from the largest entry. Number 2, use the Hungarian algorithm. So, step 1 says we need to subtract every entry in the cost matrix from the largest entry. Well, what's our largest entry? If we have a look and scan through, it's 105 so far, 110 so far, 115. So let's circle that, and that is going to be our largest entry. Now what we do is we effectively do this. 115 minus 60, 115 minus 80, 115 minus 65. You know, any single value will have 115 minus it. So we get the maximum value minus the score in every part of the table. So let's go. Operator A, machine 1, 115 minus 60 makes 55. Now with these, if you can find double ups, like if there's any other 60s, you can write that 55 again. So let's go through our process. We're going to write out 115 minus all our values. So there we have it. Now I do like to check these. The way you can check them is just finding the double ups. So 75 and 75 should match. Yep. We've got 90, 90, 90. They should match. Yep. 80. We've got 180, 80, 80. 35, 35, 110, 110. So we can see here it looks okay. So we're going to move on to our Hungarian algorithm. What's our process? Subtract the smallest entry in each row. And we've done this a few times. So let's just go through this quickly. 10, 5, 5, 0. All right, so now we've done all our values and it's just loading up there. Our next step is to subtract the smallest entries in each column. Apologies, mate. I don't know why I did that. You're probably thinking, what happened there? Oh, hang on. No, I was meant to do that. Seems a little bit unusual when they're all zeros. Just a coincidence. And our next value. Okay, so we've done that now. We've just done step 1, step 2. Now step 3 says draw straight lines so the rows and columns so all the 0 entries are covered. We've got that one there. Next one. Next one. Next one. There we go. Does the number of lines equal the number of rows? And we say here the number of lines is 4, the number of rows is 4, so yes, it does work. Therefore, we can move to step 6, we can ignore step 5. And step 6 says, select and circle the 0 entries. So what's the easiest one to do first? Well, I can see straight away that operator D has to go to machine 3. It's the only allocation for him. Now you're essentially eliminating all these, so you can scan through and go, aha, operator A has to go to machine 2 now. So now these are eliminated, we can't use either of these. So we've got this operator B has to go to machine 1, and what's left over, we've got operator C has to go to machine 4. We copy our circles at the top. Already 115 is already circled, like that. Our next step is to allocate, and as you can see we're running a little bit out of room, so I'm just going to scroll down and just draw my allocations here. So I go A, B, C, D, arrow, 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 arrow. A is going to machine 2, I'm just going to write M2 for these. Person B is going to machine 1, person C is going to go to machine 4, person D is going to go to machine 3. Then we write our number of items they make. So 90, 80, 90, 115. And then we sum them. Total number of items is 9, 18, 26. Okay. Plus, so we've got 260 plus 115. 573. So therefore we can say 375 items were made. And this is a maximise situation. So this is everyone producing as many things as possible. So 375 items made. Now let's just check the context. It just says number of items, doesn't say hundreds of items or anything like that. So therefore, we've done what we needed to do. And that's our answer there. Hope you enjoyed this video. In the next video, we'll be looking at some doing the Hungarian algorithm just more quickly, just showing the process. Cheers.